Professor Clements with you, again talking about electrical circuits, resistance, current, and power. This relates to the OpenStax College Physics textbook, Chapter 20. Our situation would be 9-volt battery connected to a long rod that has 2.8 kilometers. 2.8 kilometers for the length of the rod. And the diameter is 2 millimeters. Let's calculate the current in the rod, assuming we have 20 degrees Celsius for the temperature. Well, calculating current, we know that we're going to want to have values for the voltage and the resistance. The voltage is given as 9 volts, so our next step would be to calculate the resistance R. We do this with the formula resistivity times length divided by area. The resistivity from the table in the book is 2.65 times 10 to the minus 8 ohm meters. We put in the length, 2.8 times 10 to the third meters. The 10 to the third takes us from kilometers to meters. And then we'll assume that we've got a cylinder here. The cross-sectional area is a circle, pi r squared. So we have a radius that is the diameter divided by 2. We had 2 millimeters, that's 2 times 10 to the minus 3, we divide by 2 and then we square that value. So we have a resistance of 2.362 times 10 to the first power, 23.62 ohms. We can go ahead and calculate the current in this rod, 9 volts divided by 23.62, and we have 0.381 amps for the value of the current. We can also calculate the power in this aluminum rod. We're going to assume the aluminum is ohmic and use P equals I squared R. Power equals the square of the current times the resistance. Just up above we calculated the size of the current. I'll bring that into view for you. Current is 0.381 amps. So we know the value of the current, we square that, and then we multiply by the size of the resistance of the rod. We get 3.43 watts. A second way of calculating the power, more general way, is power is the current in the element of the circuit times the potential difference across the element. 0.381 amps is our current, 9 volts is the potential difference across the rod, and again 3.43 watts. So two ways of calculating power. P equals IV is the more general way, more applicable way. But if the material is ohmic, then we can use P equals I squared times R. Keep practicing.